All right, hello. Gonna do a quick explainer of Illusio's technology in the avatar space. What I'm gonna be talking through is kind of what we have from an IP perspective of what we had patented. This technique can be used across the board for any object, but in this use case, we're gonna be using it with faces, specifically around avatars, how you can make them hyper realistic, how you can make them usable across multiple rigs, or any rig for that case. We're gonna explain the base mesh technology that we have that creates all of that. And then I'm going to show you these things running in real time, running in the rig at real time, and all the things that kind of go to make that all really cool. So first to start, we took 3 people from the office. We had them scan their faces. We did that with a series of about 50 photos for this technique. And so what it ends up doing is kind of like you see with every scanned output, right? You get a really nice hyper detailed version of that mesh. Now it's very triangulated, very unusable for the most part. And you can see the UV texture coordinate space up here. It's all over the place. It's jumbled. If I was to apply this texture to this head, for instance, it would be all messed up, right? So we've got 3 different scans, 3 different kind of lighting conditions. But yeah, so basically we made sure to make this specific to, it doesn't need to take the entire face, right? We just did a quarter of the head. We just did, there's more around that head than this head. I cut my head off very, very hardcore. But just to give you the idea that here's this geometry that can be captured in a matter of less than a minute, just to have. And then once we have that, I ran it through our Illusio service, right? So this does base meshing technology to understand the face, use protocols to understand how to align certain things, to morph them into certain ways. And what I did was I supplied it with this base mesh that has this pre-UV layout to it. So you'll see the geometry is really clean here. The geometry is made up to be specific for a rigging purpose, right? We want it to be able to conform to all the facial structural type of things. So really clean geometry, and secondarily to that, really clean texture space, right? So after running them through, we end up with 3 different results. All of the same geometric makeup, right? All with the different bone structure to the face, all with the ways that my head, their heads all look and feel, but all conforming to all of the parameters that were from that base mesh itself. So the really cool thing about that is now each head has its own texture geometry that fits and conforms to every head imaginable. So this is our technique called unified geometry and unified texture. Once that's there, you can do a lot of fun things with it. I threw some hair on top of the head just really quickly just to show you, you could put any hair on it, you could put any hats on it, you could do whatever you want, right? But the facial structure, the build-up, the texture capability as well, like if I wanted to cartoonify this character, I could run it through a script for Photoshop, let's say, to cartoonify it, right? That was a pre-made up script. But either way, just understanding that all that geometry comes together. Now, to where it becomes really usable and really fun is when we get into the rigging process. Now, I took one rig that has all these textures that go into that singular texture space, right? The displacement maps. Every time a facial movement happens, you'll see wrinkles under the eyes, wrinkles on top of the head, all these small facial features that come into real-time rendering. All of this is real-time, by the way. And that's another thing that's really important. So you'll see, here's one head through the rig. Here's Ethan's head through the rig, running through facial expressions. I'm showing you kind of where you can control those. Obviously, all this can be done at real time, just using any visual system to understand features of the face, if that was the consideration. But you'll see all the wrinkles start to happen as we scrunch the nose up, the wrinkles on the nose, the wrinkles on the brow, all those sorts of things. Just keep running through it. Obviously, jaw movement, mouth movements internally are all there. And we just really make up all that back-end texture knowledge that we can use that one singular texture for, and it conforms across all of it, right? We can do the wrinkles in the eyelids when they close. We can frown the brow. You can see the eye wrinkles are really present here, all running at real time. So that's where it becomes really, really powerful. And then secondarily to that, just because I want to show the capability also of adding an AR component to this, right? Where that same base mesh all of a sudden has the same makeup that specular fields, reflection fields, roughness fields, normal fields, all of that stuff, I could plug in any head into this that I've run through the Illusio software, and then it'll work. So here's that same head kind of running in real time. You'll see some really nice reflection data going on, some kind of nice look and feel. You mix this with some subsurface components in there as well, and you've got something very hyper realistic. But yeah, so through the Illusio software, we're able to take any scan. And this could apply, obviously, to tables, to chairs, to anything in the world. Who cares? But in this case, it's specifically avatars. And have a one-and-done, 30-second process timed 30 to 45 second process timed output. So overall, the entire workflow could take a total of 1:30, and you're done. And then it's usable for anything you want to do. It conforms to a specific polygon count. We could take it down to however many polygons was needed. It could be 50, it could be 2,000, it could be 1,000,000 if you really care, right? Doesn't matter. But the end result is there. Thank you.